Hey, chemistry, it's Thursday, May 14th. Turn in your books to page 601. Please listen up on this today. This is real important to expose you to redox reactions. On simple redox reactions, it's easy to balance the chemical equation just by trial and error like you normally do. But on more difficult ones, redox is the way to go. And you'll see the procedures, it's 7 steps starting on page 601. So here's where we're going to start. We're going to look at the equation right here in your book. I'm right above point number 1. These 7 steps are applied to balance the reaction of hydrogen sulfide, H2S, and let's call that H2S a gas. And we're going to go with nitric acid. And that's aqueous. Gases are always dissolved in water. Then we're going to product side, we're going to get some sulfuric acid. And that's aqueous. We're going to get some nitrogen dioxide. And I believe that would probably be in the gaseous state. And we're going to get water. That would be a liquid. Now here's the question. Can you balance that thing? Give me the coefficients. Right now, go. Boom. You can't do it. It's too difficult. So you're going to use procedures of redox to do that. So we're going to break this up. Ionic equation. You remember doing that? Except if it's a gas or a liquid or a solid, we're not going to bust it up. We're only going to break up those that are in dissolved, like aqueous solution. And these 2 acids are, so we'll break them up. We'll leave these unbroken. Okay, so you got H2S, and you got a hydrogen ion. And I'm not going to write aqueous. I'm just going to do this for simplicity. Nitrate ion. And you're going to get 2 hydrogen ions and a sulfate ion. And you're going to get nitrogen dioxide and water. Okay, step 2, assign oxidation numbers. Okay, we're going to go through that whole thing. Move ahead. +1, -2. +1. This is -2. And 3 times -2 is -6. And what number do you add to -6? That comes out to be a -1, because this ion is -1. So -6 plus what number? Is 5. Gives you a -1. And this is going to be +1, the hydrogen. The sulfur, let's see, this is -2 for oxygen. There's 4 of them, so that's -8. What number added to -8 gives you -2? +6. This is -2. And so that's -4, so that's +4. And this is -2, that's +1. Let's identify redox. Oxidation and then reduction. Okay, so let's go oxidation. Looks like sulfur is going from -2 to +6. We're going to call that oxidation. And it looks like nitrogen is going from +5 down to +4. That's reduction. So now you're going to eliminate anything that's not changing an oxidation number within the formula or the ion, the species we call it. So is the hydrogen changing from here to here to here? No. Okay. So there's only going to be 4 things we're left. Because you're going to have the oxidation 2 things and the reduction 2 things. Everything else is going to go. Sulfur is going from a -2. Wait a minute. Yeah, that's being oxidized. Okay. Anyway, so this species here goes. We're just going to eliminate anything. We're going to add it back in later on. We're going to add in the water. We're going to add in the hydrogen ions later on. Okay? And so now let's go for oxidation. The oxidation half reaction looks like H2S. Leave a bunch of space and put the arrow in the middle. And then SO4, 2 negative. What that means is that the hydrogen sulfide is being oxidized to the sulfate ion. When in fact, in particular, the sulfur atom is being oxidized. Okay, and then what's the reduction? The reduction reaction is NO3, -1. Big arrow there, and then leave space here and leave space over there because you got to add stuff in, is going to become NO2. Okay, the oxidation. We're going to go back to that, and we're going to see, balance it for mass, for atoms. So there is 1 sulfur, 1 sulfur. There's 2 hydrogens. There are no hydrogens over there. And there are 4 oxygens. The oxygens, you can add them over here by adding water. You're going to have to add 4 water molecules because that's the way you're going to get your 4 oxygens, see them? But then you have to add 8 hydrogen ions over here. Okay? Now, is it balanced for atoms? 2 hydrogens and 8 hydrogens makes 10. And over there, we just have 8. Guess what? We're going to have to make that 8 into a 10. Okay? Now, the next thing. We got 1 sulfur, 1 sulfur, 4 oxygens, 4 oxygens. We're looking good. Now let's balance it for charge. We've got 0 for this molecule, and 0 for that molecule for charge. But over here we have a -2 for that ion, and we have 10 protons, 10 hydrogen ions. So it's +10 -2 would be +8. +8 is bigger than 0, so that's where you add in your electrons. Now you got a charge of 0 over here and 0 over there. So that's the oxidation half reaction. Now the reduction half reaction, we got 1 nitrogen, 3 oxygens, 2 oxygens. So how do you get another oxygen over here? You add water. Why? Because that's what I told you to do. That's the way you get that another oxygen. So now you have 3 oxygens and 3 oxygens. You have 1 nitrogen, 1 nitrogen, but now you have 2 hydrogens. So you need 2 hydrogens over here. So we're going to add 2 hydrogens. 2 hydrogen ions. Now we got our 2 over there and 2 over there. So it's balanced by mass. for atoms. Now let's balance for charge. Over here we got -1 for this ion, and we got +2. 2 minus 1 is 1. So the total charge on this side is 1, and the total charge on that side is 0. That's a molecule, that's a molecule. So which is bigger, 1 or 0? 1 is. So that's where you add your electrons. In this case, it's just +1, so we're going to add 1 electron. Well, I said you got to leave space there. I'm going to erase my arrow. There we go. Now you'll notice that you have 8 electrons up here and 1 electron down there. So what you're going to do is you're going to make the electrons the same. So everything down here gets multiplied by 8. And that would be 8 all the way across. Let's not put the end of the arrow parentheses there. Let's go like this. 8 times that whole thing. Now I'm going to go ahead and erase that because I'm running out of room at the bottom of my board. This is going to be 8 of those. Hold on. Eights are 16 hydrogens. Eight of those and 8 of those. So we got the whole equation was multiplied by 8. Okay, now, do we have the same number of electrons on the left as we do? Now we're going to combine these reactions. Okay, so we're just going to draw a line like this. And we're going to write it underneath here. For the reactants, we got H2S. And we've got 16 hydrogens. There's a reason I'm writing them in that order. It's because I'm going like this, and then like that. Okay, so as I do it, I'm just going to cross them off. Get rid of that, get rid of that, get rid of that. And 8 electrons, they're on both sides. I'm just going to get rid of those, both of those. Okay, and on the product side, let's see, we're going to go H2SO4, so we're going to go, I'm going to put this down. And then let's see, SO4s, write that down. And we're going to get NO2s, we've got 8 of those. Wait, first of all, we got those done, and we got these done, and we're going to go 8 NO2s. Those done, and 8 waters. Okay? Now, what we're going to do is we're going to go to our target equation. This, my dear, is the target equation. The only thing we need on that equation, this is called a formula equation. The only thing you need in front of those formulas is a bunch of coefficients. And that's what we're trying to do with all of this jazz, mataz. And so do we have an H2S like we need? Then in that case, the coefficient is 1. Okay? All right, now, can we combine these? So we got H2S plus, we got 16H, and we got 8 of these. So that's going to allow me to make 8 HNO3s. And how many, and that gets rid of these. And how many of these do we have left over? 8. Okay, we've got 8 hydrogens left over. And then over here, do we need water? No. So let's go ahead and say 4 on this side, 8 on that side. We're going to subtract 4 from both sides. Subtract 4 from both sides. So what does that make this? 4 waters. Put the arrow there. H2SO4, we got some H there, and got some SO4 there. For every SO4, we need 2 of the H's. Looks like we can only make one of them because there's only one of those SO4s. So we're going to call it H2SO4. We're going to get rid of our SO4. And we're going to get rid of 2 of these. So we're down to 8 of those. Now, do we need some NO2s? We got them, 8 NO2s. And do we need some H2Os? We need, yeah, we got them. We got 4 H2Os. Well, we got some leftover stuff. We got 8 hydrogens left over. But we got 8 hydrogen ions left over there too. So we're going to subtract them from both sides. And so it looks like there's a 1 in front of the H2S. There's an 8 in front of the nitric acid. There's a 1 in front of H2SO4. There's an 8 in front of NO2. And there's a 4 in front of the water. And when you looked at that by examination, you knew just intuitively that it was going to be 18184. Correct? Correct. And so if you want to read through this again, it's on page 601 to 603. And you're right now, your head is swimming because you haven't practiced any of these yet. When we're in class together in school, I spend more time with this and you practice more of them. You do homework. And then I give you a couple, 3, 4 of them on the exam, on the test. A couple short ones and a long one or 2. And so you don't have any idea how to do this, do you? But at least you were exposed to it once. Oh, by the way, did I get it right? Look on the bottom of 603 and see if I got it right. Let's see, 8 HNO3, H2S, 8 NO2, 4 H2Os, and H2SO4. Looks like I got it right. So what am I going to ask you to do for homework? Well, there's a couple ways we can do this. I can go ahead and ask you one question. The question was, did you watch the film and did you listen to me carefully with understanding? Yes or no? I think that's what I'm going to ask you. You have to be honest with me. If you take the quiz and you didn't really watch the film, I want you to watch the film because I want you to be exposed to this. Okay? All right. Next week, I'm just going to give you a couple of YouTubes that I think you'll enjoy that are less than 10 minutes long, closer to about 5 minutes each on Wednesday, Thursday next week. That's our last week. And then Monday and Tuesday, I'll give you some work out of ACT Academy again. Okay, see ya. You've done so well. You've worked so hard. Thank you.